right, let me go back to screen share. Okay. Okay. So the Pecan Pie streamer comes with multiple software options. Volumio, I would say, is the most popular one that people go for. You know, it supports a lot of functionality, including UPnP and DLNA. So it integrates with software packages like JRiver, Plex, etc. Also, if you get the My Volumio subscription, which I think is 27 euro a year or something like that, you get native Tidal and Qobuz integration if you use those streaming platforms, or you can use them through the other apps with UPnP and DLNA and not have to pay the subscription fee. And then it also supports Mood Audio. Mood Audio has very similar functionality to Volumio, but it's less user-friendly. It's more for the very techie people, I guess, is the way to put it. The Pi Core player is essentially Logitech Media Server device. So if you have like a Squeezebox Touch, the streamer with Pi Core player will act exactly like a Squeezebox Touch, minus the touchscreen. And then the Roon endpoint, for those who are familiar with Roon and what that is, that's my second most popular option for the streamer. Let's see. Okay, the Pecan Pie USB is the same exact DAC that is inside the streamer, but with a USB input. So if you use your computer for audio, or if you want to plug your iPod into the device or laptop or something like that, this is a good option. Okay. So any questions so far?
No, not for me.
Okay, so this is what the Pecan Pie DAC, this is the DAC that's inside the streamer and USB device looks like from a hardware standpoint. The front and the back of the board. So it uses I have that slide later. Oh, here we go. So the implementation of the DAC itself, it uses dual Burr-Brown PCM 1794As in monaural mode, which basically allows the device to have true balanced outputs and very good noise performance. Everything on the DAC is reclocked to a Crystec oscillator, which means the jitter performance is very good. And then for the volume control, it uses the SRC 4193. And then the device has my proprietary filtering topology for the dual balanced differential outputs stages. And internally, the device has already built in linear regulators, linear low noise regulators, so that you don't need to buy an expensive external linear power supply to make the device sound good, like you do with some DACs. And then, the headphone driver is essentially very high current op amps parallel together, which makes the headphone driver extremely high performance as well. So it's a fully linear headphone driver. So let's see. So for the test results, the device essentially achieves its full 110 dB signal plus distortion over the whole frequency range. So that's what this plot is showing.
What is that showing?
So this is showing harmonic distortion and the noise over the whole frequency range from 20 hertz to 20 kilohertz. And you can see it has full control of the output over the whole frequency range. Negative 110 dB is equivalent to 0.0003%. So it's, you know, it's very good. Okay, and then this graph shows the frequency response of the device. As you can see, it's completely flat all the way out to, actually in this graph, it just goes out to 22 kilohertz because it's limited by the sample rate of this particular test, which is 48 kilohertz. Right? If you operate the device at 96 kilohertz or 192 kilohertz, or at a faster sample rate, the frequency response goes out to essentially half the sample frequency, which is equals 3. So this plot shows the linearity of the device from essentially minus 120 dB to 0. And we could see there's just a slight deviation at 110 dB and down. And that's mostly due to the noise on the output of the device. But at those levels, you don't hear anything there anyway. So it's really, it has no effect on quality at those levels. Okay, and for this one, it's intermodulation distortion over power or over output level of the device. So you can see at lower levels, noise dominates. And then as you get closer to the full output of the device, the intermodulation distortion is somewhere between 105 and 100 dB. And intermodulation distortion measures how well the device can reproduce multiple frequencies at the same time, right? Because audio is not just 1 kilohertz. Audio is, you know, a full spectrum of different frequencies. So this shows how well the device reproduces more than one frequency at a time. Okay, and then because the device has full reclocking, this shows the jitter performance of the device. And the jitter in the real world determines how good the pace, rhythm, and timing is of the music. So as you can see here, you have the very clear spike at 12 kilohertz, and then everything else is below 140 dB in the graph.
Can you hear me? Can you hear me?
Yes.
I'm surprised at that minus 170 dBA weighted level. How do you achieve that? That seems unreal.
What?
It's not normal. That's extremely low. I mean, maybe I'm missing something, but that I don't understand.
That's clocking, not an audio signal.
Sorry?
Yes, this is averaged. So this is 16 averages. So averaging reduces the noise floor in this particular measurement.
Yeah, but that's a hell of a lot. Okay, I understand the averaging. I understand the dither averaging, but that something I don't quite understand. All right. Anyway, whatever it is, it looks good. So let's carry on.
Okay. Okay, and then here, have to do a sales pitch a little bit. You can see the specs of the Pecan Pi versus some competitors. And, you know, I believe my pricing is very competitive for the performance, you know, amongst some of the big names
Yeah.
that you're getting. I guess one spec that's not shown here is signal to noise ratio. Signal to noise ratio A weighted is 130 dB when you're using the XLR outputs. And there's not many devices at all that achieve 130 dB signal to noise ratio, period.
No.
Okay, so moving on to my monoblock amps. Right, so they're $749 each, or $1,500 for a set, which is what most people buy, or everybody buys rather. They come with everything you need. They come with the power supply. They come with RCA to XLR adapter if you only have RCA in your system. And so the amps use gallium nitride technology for the power stages, and as I showed earlier, you know, they're very compact, small, and do I have a picture of it? Yes. Okay, good. So the amplifier comes in two flavors. It comes in the traditional flavor, where like in this picture, you could see all the connections are in the back of the device. And then it comes in this inline version where the speaker connection and the power and the XLR input are on opposite sides of the device. And what this allows you to do is it allows you to put the amplifier right back up against the speaker and make like a pseudo-powered, like a pseudo-active speaker, right? Because your speaker cable is only a couple inches long in this scenario. And right, so this so in this version, it eliminates the need for, you know, expensive speaker cables, and the amplifier's damping factor is preserved by not having a large impedance from the speaker cables between the amplifier and the speaker.
I agree with that.
So any questions?
Yeah, I'm interested in your use of gallium nitride.
Yeah, I still have some more information. If there's not enough, then I can answer additional questions.
I understand. Your modulation, you use an analog modulation technique.
Right, so I'm getting to that.
Yeah, well, you are. Okay, I'll leave it there.
So it is a Class D amplifier, and the D in Class D does not mean digital. So I get this a lot. You know, many people think that the D means digital, but D is not digital. It's just another type of amplification class, which means that it's a switching amplifier. And in the case of Bosch, it is a fully analog amplifier. There's no digital components at all, unlike in some Class D amplifiers where the modulation is done in FPGAs or digital signal processors or in some other digital domain. You know, right. So Bosch is not the only analog Class D amplifier on the market, but it, that sets it apart from the digital counterparts that do the modulation in the digital domain. So yes, my modulator is a self-oscillating design with a dual feedback. I have a sort of like a little graphic showing that on the next slide, and it's I get asked this a lot, but it's completely my own design. It's not using Encore or Ice Power or any of these other Class D modules. It's it's basically using op amps and comparators in my own proprietary configuration.
Interesting.
The amplifier is DC coupled, so that means there's no bass phase shift in the music, and the bass will be very tightly controlled by the amplifier. This also means that any DC that your other devices put in will get amplified, to your speakers. So you have to watch the DC offset of your other devices. Okay, so this is what the amplification module actually looks like inside the amplifiers. So you can see sort of like the two very large silver grayish, those are the filter inductors. And then right below them, there's like these two black specks. Anyway, those are the gallium nitride MOSFETs. And they are very efficient, and that's why they can be so small without any heat sinking, right? The amplifier makes 150 watts and no heat sinks required. So that's one benefit of gallium nitride. Other benefits to gallium nitride, it switches much faster than traditional MOSFETs. Switching faster in two ways. One, you can have a faster switching frequency. And two, the slew rate of the device is much higher, which means cleaner edges for the switching waveform. So you get reduced noise, higher bandwidth, better detail, and lower distortion, because the dead time of the gallium nitride devices is smaller compared to silicon devices. And what that leads to is it leads to having a control of the speaker a larger percentage of the time, right? So any time that you spend in dead time, you have no control of the speaker, so the distortion goes up.
Interesting.
Can I just ask a question?
Okay, yeah. So as you saw in the other picture, there was the two very large inductors. That's part of the output filter. And the inductors and the output capacitors are very important for Class D amplifiers because they determine the linearity essentially of the device outside of how well you're able to drive the output. So I use devices that are much oversized for actually the power that is needed for both the inductors and the filter. And that gives the amplifier very low distortion at power levels where most people would listen to audio, right? So I have a plot of that later to show that.
Quick question while we're on this slide.
Yes.
So in the previous image, don't go back to it, the gallium nitride transistors, was there 2 per package?
Yes, there's 2 per package, so there's 4 of them.
Okay. So that makes sense. So the next follow-up question is, how do you control a shoot-through current? So if both devices are conducting at the same time, you can get high current pass through them. Do you do
Right,
anything?
so I use a standard dead time circuit, and I set the dead time, such that there's no way for both devices to conduct at the same time under worst case conditions.
Okay, so is that hand trimmed?
I'm sorry?
You hand trim that on each unit?
I don't trim it on each unit. The devices are very consistent, so once I set it for one, it's going to be identical on all the units.
Okay, good to know. Thank you.
Okay. Okay, and so it is a fully bridged design, both balanced input, balanced output, and with the dual double feedback, it essentially ensures that the amplifier is completely balanced, input to output. And because of the gallium nitride and the switching frequency of the amplifier being somewhere in the range of 750 to 800 kilohertz, it allows me to design the output filter such that there's no phase shift in the audio band at all. There's no phase shift till 30 kilohertz actually with this design, which is something that plagues a lot of Class D designs. Because the switching frequency is lower, you're forced to have an output filter that encroaches into the audio band slightly, making phase shift. So that was something that Neil wanted me to specifically discuss. Okay, so here is, so on this graph, you see the frequency response of the amp, and it's completely flat out to 30 kilohertz for both amplitude and phase shift. Any questions on this one?
Only that I was, you quoted the switching frequency as 100 kc. It seems a little low, but that's just an observation.
I'm sorry, I can barely hear you.
But it works, obviously, from the frequency response there. I've seen it keeps any phase shift out of the audio band, which is very good. Why is there a slight rise at the lower end? Can you explain that? I'm just out of curiosity, really.
Right, so there's actually no rise in reality.
Okay.
The audio analyzer is AC coupled, and there's no way to remove it. And because the audio analyzer is AC coupled, that phase shift is coming in from the AC coupling of the analyzer, not from the amplifier.
Okay.
Sorry, Richard.
Go ahead.
Sorry. Could you say something about the power requirements?
I do sell the amplifier modules separately. So if you buy the modules, it's a single-ended power supply between 48 and 60 volts. And my recommendation is minimum 250 watts.
All right.
If you buy the, if you buy my completed amps, they come with a 56 volt, 250 watt power supply.
Thank you.
Oh, so you do sell your amplifier module separately, do you?
Yes, I sell so the module that you see in this picture here, I sell that separately. So you can, build in your own power supply and your own enclosure and whatever you want to do.
Oh, that's interesting. Well, we'll come back to that. That's interesting.
Hello? I also sell my DAC, the one that you see here, by itself also. So you can either connect it to a Raspberry Pi or to, something else and do that yourself as well.
It's just the power amp I'm interested in.
Okay. Well, if anybody else was interested.
Yeah.
Leo, can I just clarify about the switching frequency? Jeff said 100K. I heard when you spoke 800K. So
Yeah,
can
no,
you just
it's
clarify?
it's
It's my 80-year-old ears, Neil. Sorry about that. That
no,
makes
it's the switching frequency is somewhere around 750 to 800 kilohertz.
Okay.
It's Jack Luska here. I have one more question regarding grounding. Can you go back to the schematic? Yeah, that one. So right now this is completely floating, and then you just mentioned that you only need a single-ended power supply. So what special interface do you use between this amplifier? It's completely floating, so one end of the power supply will be one end of both of those bridged amplifiers. So what circuitry or components do you add in between the single-ended power supply and mains for?
Well, the amplifier is not floating. Maybe it's not shown in there, right? But the two power stages, the MOSFETs, right? The high side MOSFET connects to 56 volts, and the bottom side MOSFET connects to ground.
Okay.
Right? And so each output, when it's idling, sits at half the power supply voltage, right? But when it's balanced, the two power supply voltages cancel each other. The two voltages cancel each other out.
So you set the half the power supply in the modulator.
Right. Because
Okay.
by default, the duty cycle is 50%, right? When it's idling. So you get 50% of the power supply on each of the half bridges.
And
right?
they cancel.
So, but yeah, so both out plus and out minus are going to have 28 volts to the amplifier's ground on them, right? But because it's balanced, the 28 volt cancels out. So you get 0 at the speaker, essentially.
Or you can connect the negative half of the single-ended supply directly to earth.
Right. That's what I do. Yep.
Okay. But the speaker has to be floating. So you can't, on the output of this, you can't connect either of those outputs to earth.
Right. No, you cannot. That's
The
right. The
bridge
speaker
channel.
has to
Okay.
be floating.
Thank you.
Okay, so in this graph, this shows the harmonic distortion versus power for the amplifier. And what I was talking about before with the oversized inductors, if you look at the power band between about 5 and 50 watts, the distortion is approaching negative 115 dB. And this is where I would say most people probably listen in that range, unless you have very high efficiency speakers, and then you're going to be even lower in power for most of your listening. But even at 1 watt, which is I guess the standard measurement, the amplifier still achieves negative 105 dB, and that's mostly dominated by noise. And then here, so this is distortion and noise across frequency at 10 watts. So you can see here the amplifier's distortion stays essentially flat with frequency. Okay, and then so this is what I was. So this is just showing an FFT of a 10 watt, 1 kilohertz output. And you could see that both harmonics are about 115 dB down from the main. In 99% of situations, the noise in your room is going to overshadow the harmonics of the amp in this situation, so they would be inaudible. What is this one? Okay, and then this is intermodulation distortion versus frequency. Again, you see this is typical of any amplifier. At lower power levels, you're going to be dominated by noise. And then as you get closer to full output, it improves. So basically between minus 20 dB and 0 dB, it's better than the intermodulation distortion is better than 100 dB. And then I have a comparison to some other amplifiers on the market and their performance at 5 watts. So again, I believe my amps are very well priced, especially considering they use gallium nitride. Other gallium nitride amplifiers cost a hell of a lot more, and I could not even find their specs. And I tried. So there is a couple of things that I do want to mention that I don't know. Did I have the specifications for the amps anywhere in here? Right. So the gain of the amplifier is only 16.8 dB, which is relatively low, and the input impedance is 5K. That's a design decision that I made for a couple of reasons. So one, the amplifier having a lower gain means that whatever noise you put into it is also amplified less. And two, it forces you to increase the volume on your DAC or preamp to get this amp to be at the same volume level as a more traditional amp. And that has an additional benefit of increasing the overall dynamic range of the system. The 5K input impedance, the reason for that is the lower input impedance also reduces thermal noise, just because it's lower resistance. So the amplifier is able to achieve 120 dB signal to noise ratio overall, which is also, very high end for that. But that also means that the devices that you pair it with, you have to be a little bit careful. Tube preamps probably won't work very well because tube preamps tend to have very high output impedances. But with most modern, solid state devices, there's no problem there.
That I see as a little bit of a problem, that relatively low input impedance for its applicability to other people, and also the low gain. Is that set in concrete, those values? Because
the gain is set. The input impedance, I'm working on getting that to be higher. I'm trying to figure out the best way to get a higher input impedance and keep my specifications. And I believe I have a way of doing that now.
Good.
Probably in like 6 months, the amplifiers are going to have a higher input impedance, probably 20K, maybe 40.
Oh yeah,
somewhere in that
that's
range.
more like it. I only speak from, I have a loose connection with a maker of passive preamps, and
Yeah, passive preamps won't work.
yeah,
with the 5K input impedance. That's right. Yep.
That's right.
Yep.
And when with I think it's 5 volts RMS of a maximum, isn't it? From what I read from your spec.
Yeah, to get to full power, you need 5-volt RMS into it. Yep.
That's a bit out of industry standard, really. But yeah. Other than that, I'm very interested in these gallium nitride devices. I think.
Yeah.
Anyway, yeah. Good. Okay.
That's pretty much for my presentation portion. Right, and so my integrated amplifier essentially has the Pecan Pi DAC and the Bosch amplification modules inside. So that's why I didn't have too much information on this guy, because it's essentially my DAC and the amps are the same as my other the other products. But with this product, it does have SPDIF input, which I have had a lot of requests for SPDIF, and it also has USB for the more modern modern audio components like streamers and etc. Okay, so that's the integrated amp. So any questions before I move on to do the streaming portion?
You mentioned you sold your amplifier module separately. What would be the price of those?
It's $375 per module, or $350 if you buy two at once.
Okay, and that's
Well,
on your website.
Yes, it's on the website. Yep.
Okay.
The power stage gain doesn't seem to be a lot, but my preamp line driver power stage only has a nominal 4 times gain. So that's taking the output from an Oppo disc player. We don't run out of room. The volume control is up near the maximum, but it goes loud enough. So I wouldn't have thought the fact that it's only got 16 times gain should be an issue for domestic listening. If you're going to use this amp in pubs and clubs, then that might be something else. But
Right, and I mean, this is targeted for domestic situations, right? But most amps have typically 22 to 30 dB of gain, which means that on your DAC, most of the time, you're probably at minus 20 to minus 30 dB.
yeah.
Right? And what that means is that you're essentially taking 20 to 30 dB of dynamic range out of your system, right? So with this amp, you're at least putting 8 to 10 dB back in, right? Because it forces you to put the volume up a little more than with the traditional amp.
I popped a couple of pics up on the chat of my own DAC system.
I don't know if I can see. Oh, chat. Here we go. Let's see if I.
No, we can't see it.
You can. There's a little thing, a little bubble down at the bottom. You just tap on it and you get a chat up.
Oh, yeah.
Yeah.
So I'm getting the pictures, and I'll be able to show them to everybody in a second here.
So basically, I totally agree with your choice of PCM 1794As. Operating.
So yeah, so here's the one picture that you sent. Everybody should be able to see it.
Yep.
And then.
So what I've got there is I've got the IV converters, but then I'm doing there's quite a complicated mixing of all the outputs from the DACs. What you're seeing there is each of the DAC outputs goes into an IV converter, and then all the subsequent mixing is done in the transformer primaries.
Okay, and then you have,
And then that's just an agreement with the measurements that you were making. That's the intermodulation distortion.
yeah. Yeah, the PCM 1794 is a very good device, which maybe does not match up quite with the some of the latest Sabre chips.
I don't like
but-
the Sabre chips. They've
But
got
some
a
of the Sabre
nasty,
chips are a
grainy
lot
noise
more
on them.
expensive, one, and it takes a hell of a lot more electronics to get to implement them properly, which, you know, yeah, I mean,
Yeah.
in any case.
What do people think about the fact that DSD, that I think in your DAC, the DSD converts to PCM?
Right, so my DAC only supports PCM. So if you have my streamer, the streamer converts DSD to PCM automatically. Or if you have the USB DAC, the USB chip that's inside does the same functionality. I have not heard any complaints. One reviewer said that even though there was the conversion to PCM, he thought the DSD still sounded better than the PCM files that he had. So, I mean, so much of it comes down to preference. You know, it's very difficult to say.
Yeah, I just wondered what other circle members thought about that, because that's the case for a lot of DACs, isn't it?
Yes.
Especially ones I think I've seen on the 1794 chips.
No.
Yeah, well, the 1794 chips only take PCM. So if it's a 1794 DAC, it won't have native DSD on it.
I've used one of the Burr Brown family, I think it's a 1792 or DSD 1792, which has native DSD. It doesn't go through PCM, and
Yes, the 1792 is essentially the 1794, but with a DSD.
Yeah, and a voltage output. Yeah.
Yeah.
And personally, I've used that, and I prefer that when I'm playing DSD for that reason. But that's just a personal opinion. But I just throw it in just as that's in the Panasonic player I've got here. I understand what you're saying, Paul. I also noticed that Marantz and others have actually going the opposite way. They're converting PCM to DSD in their final stages, which is almost like a sigma delta in a way. But maybe it's a marketing thing, but that's what they're doing.
No, I mean, I like the simplicity of the Orchard products. I just wondered, is the lack of native DSD seen as a handicap or something we accept for the benefit of the simplicity?
Things going wrong. What's happening here?
Yeah, I mean, you guys can keep asking questions if you like. So what I did is I accessed my streamer that I showed earlier, and this is what the interface looks like. So essentially, with the streamer, all you do is you plug in Ethernet and power, and and then you plug in your XLR into wherever, and you're good to go. And this is what the interface looks like. I pulled it up on my computer, but you can also there's a Volumio app. It's going to pull up in a second here. So there's a Volumio app on your phone, which gives you the same exact interface, but it would be very difficult for you guys to see in this presentation. That's why I pulled it up in my browser instead of on the phone. But everything that you see in the browser, you have access to in the phone interface. So that's all you do with the streamer is basically power, Ethernet, and then you get the app on your phone or tablet, and you know, you're good to go. So as you can see here, music library, so you can browse all your music. Right now I have a flash drive with some music plugged into the USB port. So I can browse that. I can make playlists. There is, you can listen to web radio. You know, there's hundreds of different web radio stations that you can listen to. There's, you know, for every type of genre that you like, classical, jazz, etc. Like here is my queue. I just made a queue of a couple songs so that you can see how it works. It's a standard queue. On the play screen itself, you know, it shows you the album cover and you know, the quality that's playing. So that's a FLAC file. So this is showing you a FLAC file. And my streamer does have the volume knob on it, but the hardware volume can be disabled by turning the knob fully clockwise, and then you can control the volume using software, so you don't have to you know, walk over to the device every time you want to change volume. You could do it on your phone or your tablet, wherever you're sitting. What else is there in here? Q.
Did you mention that you were controlling the DAC directly to control the volume, or?
So if you use the knob, it's controlling the DAC directly. But if you're using the volume control in the player, then it's software volume control.
Okay, so you're altering the current reference voltage pin.
No, it's actually still digital volume control, even using the knob.
Okay.
So it's
Because
essentially
you know you can change the I reference to give you a volume control.
right. I'm not changing the iRef on the DAC chips. It's a very nonlinear function on there.
Mm.
So it's not so easy to.
It's a quick hardware way of getting a sort of 6 dB mute if the phone rings.
I'm sorry?
It's a quick way of getting a semi-mute if you've got a simple system.
Right. Well, yeah, actually the way the volume knob functions, you know, when it's turned fully counterclockwise, the device is muted using its mute pin.
Mm-hmm.
Right. So you can do that. And okay. So, and yeah, so one of the advantages of having a DAC that is, you know, 130 dB signal to noise ratio is that when you do digital volume control, you know, even if you reduce the volume by 30 dB, you still have 100 dB of resolution, which is more than CD quality out of the DAC. With a lot of DACs that do digital volume, you don't get that because, you know, signal to noise ratio is like maybe 110, 115. So in a lot of listening situations, you're actually lowering yourself to less than CD quality, right? Okay, so what else can I show with the streamer? Yeah, so there's a settings menu. You can adjust your playback options, sources. One other good feature, if you do end up getting My Volumio, is it allows you to connect a USB CD player to the streamer, and then you can play your CDs on the streamer also. And okay, so that's that. Yeah, title and co-buzz. Like I said, I don't have the MyVolumia membership, but if I did, all you do is you put in your title and co-buzz username and password, and then you get all of that in this interface as well. Or you could do it through Bubble UPnP, because the streamer is a full UPnP and DLNA renderer. And I believe, Neil, don't you own the DAC? You're muted.
Yes. Okay. I've got the DAC and a Raspberry Pi and Volumio, and connected that up via a power supply Ethernet connection to my router, which has got a disk attached to it, so I can rip the files on my PC to the disk that's attached to the router, and then get them off onto the streamer and play them that way. And I also mentioned that theoretically it's possible to run TSP on the Raspberry Pi and get Volumio to use that. So presumably you could do digital room correction on the system.
Right, yep.
While I'm speaking, also to mention to Jeff that the process I used to actually buy this DAC, I used what they called a Revolut card, which is a kind of debit card that's very easy to convert currency on. It's it's an app on your mobile phone. You can transfer money from your bank to the Revolut card in pounds. At the tap of a button, you can convert that into dollars, at which point you could then pay Leo to buy your goodies, and he'd send them out. And I think there was about £40 worth of customs to pay when I got the package.
Yeah. So I do also have a distributor in the UK. They don't sell my do-it-yourself products. They only sell my finished products. So if you're interested in the do-it-yourself products, you still have to buy them directly through my website. But you know, like the fully built streamer, the fully built amps, you know, you can go through the distributor. Of course, you know, my preference is you get them directly through me, right? Because I don't lose the distributor fee. But you know, the distributor is an option because I did have a lot of people asking for that. So it helps with the currency conversion and etc. Right?
Can I just ask a bit more about the modules, the amplifier modules?
Yes.
I'm quite interested in these, but I wonder if you could say, I'm sorry to go on about this, but I'd wonder if you could say a bit more about the power supplies. Presumably you use SMPS. Yeah, SMPS.
Yes. I can, give me 1 second. I'll actually bring the power supply that ships with my amps over so you guys can see it.
Oh, thanks.
Oh, he's gone. Okay, whatever you say, he won't hear. But we're recording, so maybe he will hear. I know the stuff looks pretty interesting. I just did a quick patent search, and the power modules aren't patented.
So to partially answer your question, here's the size of the amps, right? And here's the power supply, and you can see why the amp is so small, because the power supply is external.
That looks like a standard switch mode power supply. Is that right?
Yes, this is a standard switch mode power supply. And one of the reasons I could get away with this is because of the amp's fully balanced design. It has a very good power supply rejection ratio. So I don't cheat with when I do my measurements, like for the specifications and everything. I do it with the power supply that ships. It's not like I test the amp with a linear power supply and then, you know, throw a switch mode power supply in the package, right? That's not, I don't do that.
Do you find that a commercial objection? Forgive me.
And another reason that I went with commercial power supply is that the commercial power supplies, you know, like this power supply supports, you know, voltages from all over the world.
Yeah, I understand
And
that.
it has,
Yeah.
you know, all the certifications
Yeah.
and everything. If I were to do that myself, you guys be paying 20 times that for the.
I
for
know
the
that in
equipment.
spades. Yes.
What's the maximum voltage you can put on these amplifiers? I mean, if you're running it off one's own power supply.
60 volts would be the maximum.
Okay.
So the voltage that you run them at also determines how much power they can output into a certain load, right? Like for example, at 48 volts into 8 ohms, you would only get 100 watts of undistorted power, right? These power supplies are 56 volts, so I get 150 watts. If you put 60 volts, you're going to get a little bit more.
Right.
So I have a question on speaker impedance. Your website states you recommend 6 to 8 ohms. What is the warranted range of speaker impedance that you can drive? Down to 1 ohm, for instance?
Down to 2.
Down to 2.
Yes.
Okay.
I'm not sure where you saw that I recommend 6 to 8.
Oh, now you got to go back to your website and have a look. Yeah, I can show you on my phone. Yeah, it's there on your website. Under when you purchase the thing, it says, oh, that's the, sorry, I'm on the
On
wrong
the
one.
purchase page?
Yeah, and it's the specs part of the purchase page. So let me see if I can get that. That's the DAC, and this is the Bosch amplifier, gain, and then, yeah, gain recommended for 6 to 8 ohm speakers. So it's where you've got a bunch of specs on the amplifier page. So you can go down to 2. Does that mean you derate the voltage of the power supply to get there?
Hold on a second. No, I want to make sure, because what I used to sell is I used to sell the amplifier with 2 different gains. And when I sold the amplifier with 2 different gains, is like one gain was targeted for 8 ohm speakers and one gain was targeted for 4 ohm speakers. But I went away from that and I only sell this one gain, which is 16.8 dB. And the amplifier itself can drive down to 2 ohms. But essentially the power supply is going to limit its power to 150 watts, regardless of what impedance you're driving, right? So
what happens if you accidentally short the output?
Go ahead,
the
Susan.
overcurrent protection will kick in.
So you do have protection on the board.
The protection's in the power supply, not on the board itself.
So if you make your own power supply, possible to burn out the chips by abuse?
Yes.
Okay.
I think there's a little handy component called a fuse, which might be a good idea to have in a linear power supply.
Right.
Depends how quickly it blows.
Yes, the the gallium nitride devices are very robust, and I've tested them where, you know, I short the output, and even though the overcurrent protection is not directly on the amp, the overcurrent protection from the power supply is fast enough to protect it from damage.
Okay. So that one last follow-up question. I noticed you're based in New Jersey. Where is your manufacturing? Where do you cite that?
Well, it depends what you're asking about, right? So my circuit boards, some of the circuit boards are manufactured in New Jersey. Some are manufactured in Canada. And if you're buying a finished product, I actually assemble it. I assemble the finished products myself.
Okay.
Right. So I assemble and test them myself. So yeah, so everything's out of New Jersey pretty much, except for I have a couple of circuit boards coming from Canada. But yeah, no Chinese manufacturing.
Yeah, I got no problem with Canada. I'm living here now.
Okay. But yeah, I mean, if you can find that specific thing where it says recommended for 6 to 8 ohms, I'm gonna remove that, because that's no that was from previously, and it shouldn't be there anymore. I thought I did. Anyway, okay, but I'll take another look at it.
Anyway, I'm impressed with your amplifier. I think this use of this new gallium nitride is may take Class D to it. I've been playing around with Class D for some years, and I've always not been 100% happy with them. This may remove that difference, I hope. So it's very interesting. Thank you for your.
Yeah, it's not only the gallium nitride, right? I think my my modulator and filter design, you know, also make a very big difference.
Oh, sure, but doesn't this new device allow you to do what you're doing?
Well, yes, that's part of it. That's right. Yep. Yeah, because switching 56 volts, you know, at 800 kilohertz is not a simple task.
Absolutely.
Do
So
you do
I
anything
was,
special to damp the RFI?
So the output filter removes the switching frequency from or mostly removes the switching frequency from the output, right? And the amplifier itself is in a, well, depending on which version you get, is in a steel case. So that stops the rest of it. But you know, there's also filters, and the circuit board design heavily influences how much it radiates also. So, you know, I limit heavily all that stuff.
Good.
just a question about your modulator. Obviously, companies like TriPath and Hypex have sort of might have started with simple modulators, and then they keep coming up with new and better designs. Is your one going to follow the same path, or do you think yours is fairly stable?
I'm not sure what you mean by stable.
Well, is there going to be, or do you think there might be a version 2, a version 3,
Oh, I think
new
that's all
iterations of the
inevitable.
product?
Maybe. I don't have anything planned right now. I've actually spent my first amplifier design that I talked about when I started the presentation for the audio system for my house. It was based on the same modulator technology. So this modulator has been improving since about 9 years ago now. And with the gallium nitride, it allowed me to essentially increase the frequency, but keep the modulator more or less the same. I believe that the performance you get with it is already top of the line. Right now, unless there's some other technological change, similar to like going from silicon to gallium nitride, I don't see a change to it, in a sense, because I think it would be very difficult to improve on the performance it already gets, without maybe changing it to something completely different.
But sometimes there's always a marketing reason to bring out a new one, that's
Right. Yeah. I mean, people like to, always have the latest and greatest, but,
Yeah.
Right now with the gallium nitride, you're going to get that, you get that.
I think you're on the beginning of that change, so you've got a lot of mileage left.
Yeah, and it wasn't, I can't say that, I designed this thing, and the first time I turned it on, it blew up, right, as anything goes. And, there was
well, we know that.
almost, I want to say 6 months to a year of experimenting with different gallium nitride FETs and et cetera before, I got something that I was happy with, right? And then, there was always that little tweaking here and there to, get it to where it is now. So yeah, I think as far as the gallium nitride technology goes, I'm ahead. Because I've already spent 2 years on it, where a lot of companies are just, starting to get into it.
So, but the main thing is, what does it sound like? Like, and I noticed you've got a distributor in the UK. I guess most of us would like to hear things before we buy. So,
right. So what I have done with other societies is I send some sample units out to the organizer or whoever you deem to be the organizer, and then they pass it around amongst the members, so the members can try them. So, if Neil or one of you other guys wants to, organize something like that, I'd be happy to send, the amps over, for you guys to try them.
That's interesting.
The distributor is or will have a listening room set up, but due to the whole COVID situation, that's not going to be for some time yet, right?
Okay.
Because they don't want anybody coming in, et cetera. So.
No, not with the current situation. Absolutely, yeah. He's in the UK, but where is your distributor? Where is he in the UK? I couldn't see on his website.
I don't remember off the top of my head.
Okay, don't worry. Don't worry. Don't worry if you don't want to say. Okay.
So this is the distributor.
Everybody here.
Let's see about.
Hey, Leo.
Yeah.
You've got dual feedback in the Bosch amplifier, and there's the outer feedback loop from the other side of the inductor, basically at the speaker terminal. I assume that sets gain. It's the standard feedback. But the inner feedback loop is going to see the full output square wave. So how do you deal with that output square wave? Do you take it back to the triangle ramp, or do you use it as a comparator somewhere else in your circuit?
Well, there is no triangle wave. It's a self-oscillating design. So the feedback from before the inductor is actually part of what sets the switching frequency of the amp.
Okay.
So it's using essentially the square wave of the output as the to sample the input.
Okay.
And then
right.
Yeah, the feedback from the other side of the filter helps to partially helps with getting rid of the phase shift, after, that the filter typically would put in.
And it sets the gain, right? You've got a voltage divider.
Well, actually, both feedbacks set the gain, and yeah, I don't want to give away too much there, but they're both setting the gain in a way.
Okay, interesting.
Well, a similar thing. The second feedback loop, does that reduce the impact of the filter on in conjunction with the loudspeaker's impedance in setting some of the frequency response? Does it? Some of the other Class D amps that I've had, you had to adjust the filter. Sorry, I can't explain myself very well. In conjunction with the loudspeaker impedance to make sure you didn't get a peak or a roll off in the frequency response. Does putting the feedback loop there remove that, or do you still have to take into account what loudspeaker impedance you're driving?
Yeah, no, the amplifier, yeah, with the additional feedback loop of directly being from the output,
yeah,
it doesn't care what speaker you connect.
Okay.
The speaker impedance is taken out of the equation. It completely compensates.
Well, I was
for it.
hoping. Good.
So anyway, let's see where these guys are, if they have anything in here.
So, Leo, I got to really thank you for a comprehensive presentation. I really enjoyed that.
Yeah.
And yeah, I thought you presented the 4 devices that you sell really, really well. Got me quite interested. Thanks you very much.
Okay.
Yes. Me too. Thank you very much. I would be, if I don't know if Neil would be willing to organise getting hold of at least a Boss amp anyway. I'd be very interested to hear it.
Yeah, and me too. Yeah.
I'd be interested to see what the DAC sounds like.
You up for that, Neil?
That should sound very nice.
Well, I was going to say, if you want to hear what the DAC sounds, you can listen to my one, which you did.
I'm happy with the TDA 1541 at the moment.
In terms of the amp,
I really am interested in in hearing the amplifier, I must admit.
Yeah.
It does seem to be the future.
Yes, I've heard it in the context of your system, Neil. Yes.
This amplifier looks interesting. So to see whether, yeah.
all right. Then after the meeting, I'll have words with Leo and see what we can arrange, and if I get anything, I'll send it out to you.
I was early. Got involved with Tripath Audio, as you may remember. Leo, do you know them?
I've heard the name. Yeah.
Yeah, they were the very early people in starting try to sell Class D amps. It was an interesting technique, and then later on, I've now got UCD myself. I use for a bass amp, but for me, the Class D amps that I heard were promising. But there was always something slightly wrong in what I think was the treble for me. It wasn't natural, and I tried very hard, because up until recently I was very much a solid state man. But I've got religion, and now I'm a single-ended triad man. But I still keep an open mind, and I'm very interested in this development. So yeah, if Neil can arrange something, I'd be interested to listen to it. I'd like to hear what it has to do. So, okay.
Same here, and thank you, Leo. It's very interesting.
Thank you.
Okay.
Yeah, thank you very much.
All right. Okay.
Yeah, thank you very much, Leo.
And thank you very much for your time. Yeah.
Very, very impressive enterprise. Take my hat off to you.
Yeah. Wish you the best.
Thank you. Yeah, so here's my contact information again. If you guys have additional questions, you know, feel free.
Before everybody goes, I'd like to chime in a little bit. First, I apologize for getting late. My name's Todd. I'm in the US. I am a customer of Leo's. I have bought the Star Crimson monos as well as the Pecan Pie Streamer. And I can attest to how well they sound. I have a pair of ELAC FS207 Anniversary Edition speakers. I have also started my digital journey with TriPath. And one of the things that I just could not stand about it was the variability of the frequency response with the output, the speaker impedance. And I agree, digital amplification did not just do it for me until it started getting a little better with the HyperX chips for me. And I gotta say, what Leo's done with these GAN chips are fantastic. The closest competition they've got, and it's 1A, 1B, depending on what your criteria is. I've got some of the, oh crap, I forgot the name of it. The person, Bruno, who created HyperX, just started his own.
Oh, Purify. Encore, yeah, Purify.
Yep, the Einkat, with custom input buffers, because their evaluation board apparently sounds very good, but not the best it can be. And I got to tell you, the Star Crimsons, the Bosks, they are like neck and neck with I would call this the best amplification I've heard.
It's actually good that you brought that up. So the Bosk name is going to be changing over to Star Crimson because of Bosch GmbH in Germany. They contested my trademark. So Bosk will, in the next 6 months, not exist, but whenever you see Star Crimson, it's essentially, you know, the electronics and everything is identical in all but name. So, and like, that's why the amps that you got, Todd, say Star Crimson on them, but, you know, it's still called Bosk on the website.
I did have one question. I apologize again to go back to a previous topic. You talked about the USB chip doing the resampling of things like DSD. Right now I'm using Rune, and I actually do that in Rune. Do you think it would be better to do it at the hardware level and feed the Pecan Pie Streamer the full signal, or?
I'm not sure what you mean, do it at the hardware level.
You had mentioned that the Pecan Pie will do the sampling. So if I feed it a DSD signal, it'll resample to PCM, correct?
Well, yeah, Rune is doing that for you. It's doing it through Rune. It doesn't,
Okay.
it in the hardware itself, it does not do that.
Gotcha. Okay, I thought you had mentioned something about the USB receiver doing that. Okay. My apologies.
Yeah, when you have, so I have another product called the Pecan Pie USB, which has the same DAC as the streamer, but it's a USB input, right? So, but the USB input handles that same functionality. The DAC itself has no hardware to do that conversion. It's all done in software.
Gotcha. Okay. So if I were to pick that up, which I am thinking of, by the way, would it be better to feed it the full or keep doing it in Rune and have whatever network streamer feeding?
Well, Rune is going to keep doing it for you regardless of what device you have.
Okay.
So yeah, I don't think you would hear any difference.
No, I know my my DSD content right now does sound fantastic, and it still sounds different than the PCM. But even though it's resampled to PCM, it's sounding very, very good.
Okay, thank you.
Oh, thank you, everyone, and thank you, Leo.
All right. So any
Thanks
other
for joining our
questions?
meeting.
Not from me.
Okay, all right, I'm gonna end the meeting then. So I think everybody's gonna get disconnected once I end it. So
Okay, thanks, Neil, for organising.